Hello, everyone. So let's solve a Leetcode problem today, and this is one of the problems within the blind 75 list. And this is a very simple problem, yet so important. So this is binary search, and we have to do binary search a lot of times, like in different, a lot of times during solving different problems. So we need to learn it. Like not only you need to have the clear concept, we need to do it pretty fast, because in most of the problems we'll be doing it not as the real problem, instead probably as part of the problem. So we need to have a very good understanding of this problem. So let's go to the problem description. Given an integer array of integers which is sorted in ascending order, and you are given an integer target, we have to write a function to search target in the array. Okay, so we have to search target into the array, and if the target exists, then we return the index, otherwise we return 1. And my algorithm needs to be in order of log n. Yes, that makes sense. So here is the first example. You are given an input array, and the target given is 9. So you see that 9 is there, right? 9 is there. So we have to write an algorithm of log n order, which actually returns the index 4. Okay. And then in the second example, you see we are given the same array, same input, but this time the target is 2. But 2 is nowhere in the array, so eventually it should return -1. And this algorithm needs to be in order of log n. By order of log n, it means there are like 6 elements here, so the algorithm should be in order of log 6. Okay, so let's think about the problem. Two things. First of all, probably you can already by now the naive way to find this, right? So what you can do is we can just keep on reading each of the elements, right, from left to right, and to see if 9 is there, right? And the thing is, since this is an array, in the worst case you have to read like all n elements, so it's going to be an order of n algorithm. Of course, you can stop when your value, like the values of the array exceeds 9. But the thing is, suppose you don't know, like suppose your say even in this case you had to read everything, right, until you almost had to read, like in the worst case you have to read all of the elements. So it's order of n, and obviously this is not the algorithm that they're wanting, right? So that's a linear search, not binary search. The other thing is, like when we actually studied array, we know that the arrays have these indices from 0 to say 1, 2, 3, 4, 5. So once you know the size of the array, it's so easy to access any random element. So if their name of the array is A, you can just go, if someone says what is A3, you can just directly go here and grab the value, right? So the access is so easy. For the same reason, if you know the size of the array, you can just find the middle. So this is what binary search does, right? So you go to the middle, and then you search for your number, and then you can decide whether the number is in the left side, on the right side, and then you can just get rid of half of the search space. Okay, and that's what binary search is. So let's say here, let's say for the first example, right? For the first example, sorry. Or let's go to the second example here. So it's -1. How many elements are there? There's 6 elements. -1, 0, 3, 5, 9, 12. Okay, so what we can do is, for a binary search, we will go to the middle. Here the middle is going to be, say, this. and then we check if 2 is greater than or less than 5. We know that 2 is less than 5, so we immediately know that this is done. We are done with this part. That means initially we were searching like n elements. Next time we're going to search in n over 2 elements. So we are getting rid of the half of them, right? Okay, and so next time my middle element is going to be this one, right? So this time I'm checking if 0 is greater or 2 is greater. So we see 2 is greater than 0, right? Now I know that I can just get rid of this portion, the left portion, right? That means I had n over 2. Now I am getting rid of the other half. So it's n over 4, right? So it's n over 4 now, or 2 square. And this time I have only one element. And obviously the middle is going to be this, okay? And obviously 3 is not equals to 2. So we're done. So after like 3 steps, we can say we're done. And that is actually 3 is like log of 6, right? So that's a log n algorithm. Okay, so how do I find the middle? A few things. I know my high index and low index. The low index is 0. The high index is, say, if I can get it from the length of the array, right? Array length -1, right? Which is 5. So I can find the mid index. We can say 0 plus high minus low divided by 2, which is depending on like it's 5 over 2. So we take the rounded value, so it's 3. That's how we find the mid index, okay? And we keep on doing this in every step because we get rid of the half and then again we try to find the mid. An important thing to notice here is why did you do this, right? Why do you do this? We could have actually done in a different way. Say mid equals to high plus low divided by 2. We could do this. Here is one thing, because the integer has in most of the programming languages, integer has a like highest limit, right? High limit. So it might be the case that your array is so big that once you add these two things up, they may cause an overflow of integers, and then your program will actually throw an exception and crash. So that's why we want to avoid this. Instead, if we do this, right, even if your high is very high, we're subtracting something from it. So there is no chance of overflow. So that's why this is the one trick that you should remember. Okay, so let's go to our, let's try to program this. I already have programmed this. I'm just going to explain this to you. Okay, so here is the problem. Okay, initially you see I get my low index 0. So this is the input and this is the target value. And I have to return the index of the target value. And if the target value is not in my input array, in that case, I return -1. Okay, so I get the low and then I get the high. High index is this array length -1. Okay, then I define this mid. This is important, right? I just declare this mid. And how long I will do, like, keep on searching, right? I will keep on searching until my high index is greater than equals to my low index, right? Okay, and one thing here, like, remember one thing here, my high and low index are going to like change. You see, initially my high is, say, look at this one. So initially my low is 0, high is, say, 5, right? So mid is in the middle 3, right? So mid was here. Okay, so next what we did is we were looking for 2. So we actually got rid of all of these, right? So what happens is low still remains the same, but high now changes to 2, right? And so mid becomes 1. So that means depending whether why this is the case, this is the case because 2 was less than 5. That means I know that if I have a 2, it's in the left side. So can we say that, like, if my target is at any point, if my target is less than the mid value, say this is the input, in that case my high changes to 1 step ahead of, like, my new high becomes this, right? So mid -1. Okay, but if my target was like greater than input's mid value, say my target was, instead of 2, say my target was, say, 6. Okay, my target was 6 instead of 2. So what I would have done is initially my low would have been 0, high would have been 5, mid would have been 3. Then I would have checked 6 again as this, and then I would have seen, oh, okay, 6 is greater than 5. That means obviously 6 is going to be somewhere here, right? So I have to get rid of this. Okay, so what I could do is if my high is like if my target is greater than the input mid, I could actually get rid of this. Okay, then I could just say new, not high. Now the high remains the same. My low would have changed to mid +1. Okay, that's the thing. And the most important one, that if at one point my target becomes input mid, so it matches, then just I'm done. I found my thing, right? Return the mid, which is because I need the index. Okay, so let's go back to the code again. So, and I keep on doing this because you see the high moves, high and low actually keeps on moving, right? So low moves to the right, high moves to the left. So I have to keep on doing this until my high index is greater than equals to my low index, right? I have to keep on doing this. This is important, greater than equals to. The reason is, suppose you have just one number, in your array. In that case, your low index and high index is going to be the same, right? But still you have to search for the target, right? So if you just say high greater than low, it's not true. So you are not even searching anything. So yes, so you have to do it like keep on doing it until the high doesn't cross the low, right? High doesn't become smaller than low index. So until the high index is greater than equals to the low index, first thing I do is I calculate the mid index using that technique, right? And then I check if my mid index number matches or equals to the target. In that case, I return the index, I'm done. Otherwise, if this mid index number is greater than target, if it's greater than target, that means I know that my target is in the left side, right? In the left side. That means my low index remains the same, and my new high index goes to the left. That means mid -1. Otherwise, it means that if none of these two cases are true, that means my mid index number is now smaller than the target, right? It's smaller than the target. That now it means that, okay, I have to search in the right side of the array, That means I change my low index to mid +1. Okay, so I keep on doing this. Every time my search space becomes like reduces by half. So until I keep on doing it until basically this one becomes true, or you can say until my search space becomes 1, or so in the worst case, I just keep on searching and then I don't find anything. In that case, even in that case, I am doing it like login times, right? If after doing all the things, still I don't find my target, I just return -1. Okay, so I did this, and this was like pretty fast. And obviously, time complexity is order of log n, right? Order of log n. So, every time I'm getting rid of half of the search space. So how many steps I have to do? We saw like in this case, there are 6 elements. In the worst case, I have to do this thing while loop, run this while loop 3 times, right? Yeah, because log 8 is 3, so log 6 is roughly 3. Okay, it's 2 base log. And the space complexity, well, we are not using any extra space. Okay, we are not using any extra space, right? So it's constant. I'm not storing any data in any extra space. So hopefully this was clear to you. I suggest everyone to code this. This is very important. Code this because sometimes I know the concept, everything, but unless I code it, I keep on doing some mistakes. So this is one of the very important problems. And with the concept of array, you got some concept of the array, the random access in the array, and how an ordered array helps in binary search. We had discussed all of these when we discussed array, but this is a practical example and a problem to visualize all of that. Thank you everyone for watching. We'll come back with another problem.